You step into the coding arena once again, ready for the next quest. The developer glances at you and says,
Given an integer array nums, return true if any value appears at least twice in the array, and return false if every element is distinct.
At first glance, it feels almost too easy. Just check for duplicates, right? But as always, the real challenge lies into solving it efficiently. I'm Ivasuta Alexey, and today we are solving the contains duplicate problem from LeetCode. Today's problem is a classic from the world of coding interviews. Contains duplicates is simple, clean, and surprisingly common. So let's start from carefully examining the task. We are given an array of integers nums. Our goal is to check whether there are any duplicate values. If there is at least one value that appears more than once, we return true. Otherwise, we return false. Let's look at a few examples to get a better feel for the quest. The first example. We are given an array 1, 2, 3, and 1. Here the number 1 appears twice, so we return true as a result. Next example. We get an array 1, 2, 3, and 4, and all values here are unique, so the result is false. In the last example, we get a larger array. There are many values that repeat here, so again we return true. So, how do we approach this problem? Let's begin with the most straightforward approach, brute force method. We just need to compare each pair of elements in the array. Start with the first number and check if it is equal to any of the numbers that come after it, and do the same for each one. Here's how it works. We start a loop with I going from 0 to the end of the array. Inside that, we have another loop with j starting from I plus 1. Starting j one step ahead helps us avoid comparing elements with themselves, and also stops us from checking the same pair twice. For example, if we have already compared nums at index 0 with nums at index 3, there is no point in checking nums at index 3 with nums at index 0. It's the same pair. For each element at index I, we compare it with every element that comes after it. If we find a match, we return true right away. If we go through all the pairs and don't find any duplicates, we return false at the end. It is simple, but how fast is it? Let's talk about time and space complexity. The brute force solution goes through all possible pairs using nested loops. For an array of size n that can be up to n multiplied by n-1 divided by 2 comparisons. The time complexity is big O of n squared, and it is fine for small arrays, but it gets slow as the size grows. On the bright side, we don't have any extra memory, so the space complexity is constant big O of 1. Not ideal solution. Let's make it better. There is a much faster way by using a hash set. Instead of checking each number against every other one, we can scan the array once and keep track of what we have already seen. Let's walk through an example. We have an array of numbers 1, 2, 3, and 1. We start with an empty set. The first number is 1, and we check if it is already in the set. Since it is not, we add it. Next up is 2. It is also not in the set, so we add it as well. Same with 3, not in the set, so we add it. And finally, we get the last number, another 1. This time, when we check the set, we see that 1 is already there. That means we have found a duplicate, so we can return true and exit the function right away. If we go through the whole array without finding any duplicates, then all elements are unique. In this case, we return false. This approach is simple and works well, so let's go ahead and write the code. We start by creating an empty set to store the numbers we have seen. Then we loop through each number in the array starting from index 0. If the current number is already in the set, we return true. If it's not, we add it to the set and keep going. If we make it through the whole array without finding any duplicates, we return false. Now let's analyze the optimized version. We process each element exactly once. Checking and inserting in a set are both constant time operations, so the time complexity is big O of n. We use additional space for the set, so in the worst case we store all n elements, so space complexity is also big O of n. This is a big step up from the brute force approach. As you can see, this way is more efficient. But there is one more bonus method I'd like to show you. Imagine the array is sorted in ascending order. In that case, any duplicate values would always appear next to each other. So all we need to do is go through the array and check if any two neighbor elements are the same. If we find a match, we return true. Let's write the code. First, we sort the nums array. The specific order doesn't matter here, so we'll just use the default sort. Next, we start a loop with I running from 0 to the length of nums minus 1. At each step, we compare the current element with the next one. If they are equal, that means we have found a duplicate and should return true from the function. Note that the loop runs while I is less than nums length minus 1. This prevents errors from trying to access an element that doesn't exist, like nums I plus 1 when I is already at the last index. At the end of the function, we return false if no duplicate values were found. As you can see, sorting the array makes the solution much simpler. However, let's take a look at the time and space complexity of this approach. First, we sort the array using num sort. In JavaScript, this uses an algorithm called team sort, which runs in big O of n log n time in the worst case. After sorting, we go through the array once to check for duplicates. That part takes big O of n time. Since n log n grows faster than n, the total time complexity of this approach is big O of n log n. This approach doesn't use any data structures, but the team sort algorithm itself typically requires up to big O of log n space during sorting. So the space complexity of this solution is big O of log n. So today we knew 3 different ways to solve contains duplicate problem. First, we'll look at the brute force method, simple but not efficient. Then we stepped it up with fast and clean hash set approach. And finally, we checked out the sorting trick. Each approach has its own strengths, depending on what matters most in your case. Speed, memory usage, or code readability, one could be a better fit than the others. If this breakdown helped you to get a better grasp of the problem, don't forget to like the video, subscribe to the channel, and hit the bell so you never miss the next video. Thanks for watching and see you in the next code quest.